Hello, this is Mrs. Taylor, and I'm going to introduce you to the chain rule with trig function. So, before we get started, we need to learn what the rules are. And the idea is that if you write a function using u instead of x, it's understood that u represents some kind of inner function. So we're dealing with composites here. That's why we're using chain rule. So when it says d over dx of sine of u, what that indicates is you're you're deriving with respect to x, and this u represents the fact that there's some kind of inner function here. And so you use the chain rule, you take the derivative of the outer, which would be derivative of sine, which is cosine, and then derivative of the inner, which would be represented by du. So the way we write the derivative of sine of u with respect to x is cosine of u times du. And then tangent would be secant squared, but don't forget your times du. Secant would be secant tangent. And then, of course, when you have your co-functions, they're basically the counterparts, but are also negative. So cosine is negative sine, cotangent is negative cosecant squared, and then cosecant is cosecant cotangent. And the key is that you do not ignore this du. That's derivative of your inner function. So let's look at a couple of chain rule problems. So sine of 2x, we're looking for the derivative. 2x is your inner function. So if I were to write the derivative, I would say y prime. Derivative of sine is cosine. Leave the inner alone, so 2x times derivative of the inner, du, which would be 2. Derivative of cosine of x minus 1, well, that would be derivative of cosine, which is negative sine. Leave the inner alone, times derivative of the inner, the du, which is just 1 in this case. And then for tangent of 3x, y prime, derivative of tangent is secant squared. Leave the inner alone, times derivative of the inner, which is your du, which is just 3. So those would be some pretty straightforward chain rule problems with trig. Now the tricky ones are those that are chain rule within chain rule. So let's say that we have f of t equals sine cubed of 4t. So what I have is I have this cubed, which is an outer function, making my inner function sine of 4t, which is also a composite function. So I have chain rule within chain rule. And when I took my certification class, our teacher introduced us to the ETA rule. It stands for exponent, trig, and then the last one would be angle. So the idea is that you take the derivative of the exponent, then the derivative of the trig, then the derivative of the angle, which is 4t, and multiply them all together. And with each step, you leave everything you're not touching alone. So when you take the derivative of the exponent, you leave the trig and angle just as it is. Treat it like a stamp. So for example, for this top problem here, f prime of t, I'd work with the exponent first, which is at 3. And so I would use the power rule, and I leave the other two, the trig and the angle, alone. Now, I get to the trig part, and when I get to the trig part, I leave the exponent alone. I leave it behind. So this 3 goes away, and I just work with the trig. Derivative of sine is cosine, and I'm not at the angle yet, so I still write the angle just like it is. And then when I get to the angle portion of it, well, I've already done exponent and trig, so I'm not looking at either of those. I'm just looking at the 4t, so derivative of 4t is 4. And so this would be my derivative using the ETA method. So another example down here, we have find the derivative of y equals 3 times tangent squared x. My exponent is that 2. And remember, when you use power rule, this is a constant 3, so I just do 2 times 3, which is 6. Subtract 1 from the exponent, which would just be 1. Okay? And then the trig part, so I need derivative of tangent, which is secant squared. And then I get to the angle part. Well, the angle is x, derivative of x is 1. So I could just write that or just leave it off. And then, if I wanted to clean this up, I'd say 6 tangent of x times secant squared x. So that's how you would use trig and the chain rule together.